Good morning, Gear 4. So today we're going to finish talking about the thermal energy lesson. We're going to talk about heat conductors and insulators. And then the next week we will start finishing some of the worksheets related to this lesson. But before discussing heat conductors and insulators, we're going to correct your homework page, or last homework page 45. And then we're going to take our lesson and do a little fun activity about it. And then we are going to solve some worksheets as a classwork, pages 49, 50, and 51. Then I'm going to introduce you to your weekend homework, pages 46, 47, and 48. And at last, we're going to watch a video showing an experiment that helps you differentiate between conductors and insulators. Before starting this lesson, I just want to get a little bit back to the force lesson. And I want you guys to remember with me this specific question, where it says, where would you feel the heaviest, on the earth, the moon, or you would feel equally heavy on both? And at that time I told you that the answer is you would feel equally heavy on both. After discussing it and searching a little bit about this, because I was a little confused about it, I reached the conclusion that this question actually have two answers, two valid answers. The first answer is, if we are talking about mass, if this question is in terms of mass, as I told you guys, mass is the amount of matter inside an object. And if you remember, I told you that if I'm filling a bag, which is the object, with a certain number of books, though this books is the amount of matter inside the bag, inside the object. And if I took this bag anywhere, to the moon, to Mars, to Venus, to whatever the place I'm going to take the bag with, the number of books inside the bag will never change. And this what mass is. Mass is the amount of matter inside an object, and it never changes. So if you are talking, or you are answering this question in terms of mass, so your answer would be you would feel equally heavy on both. And if you are talking about weight, if you are answering this question in terms of weight, I told you guys in the same video that weight is always related to the gravity of the place you are in. So if you are measuring your weight on Earth, it's going to be different from if you measured your weight on Mars, because the gravity on Earth is different from that on Mars or on the moon. So if you are talking, or you are answering this question in terms of weight, your answer should be the Earth. You would feel heaviest on the Earth because the gravity on Earth is higher than that on the moon. So this question has two answers. In order to answer this question, if you ever faced it in a quiz or in an exam, I want you guys to write between brackets how would you answer this question according to mass. Then the answer would be this one. Or if you would like to answer it according to weight, then you will write weight and you will answer it the Earth. Now let's answer or correct the homework that you took last time, which was worksheet 2, page 45. Look carefully at each thermometer. For each one, write A, the highest temperature it can read, B, the lowest temperature it can read, C, the temperature it is currently showing. So this is a very easy question actually, but some of them would be a little bit tricky, and we're going to discuss it right now. So the first one is a really simple one. You just have to see where is the highest temperature that this thermometer can reach. It's apparently 70 degrees Celsius. And the lowest temperature this thermometer can reach is 0 degrees Celsius. And the current temperature we read according to the level that the liquid inside the thermometer reached, and in this case it's 20 degrees Celsius. Now let's look at this one. So the highest temperature this thermometer can reach is 50 degrees Celsius. The lowest temperature is minus 20 degrees Celsius, and the current temperature is minus 10 degrees Celsius. And let me just clarify something to you guys, that in terms of the minus, under 0 degrees, when the number gets bigger, it means that the temperature is lower. So this means that minus 20 is actually lower than minus 10 degrees Celsius. Now let's answer this one. The highest temperature on the thermometer is 30 degrees, and the lowest temperature, as you can see, is 0 degrees. The current temperature that the liquid reached is between 30 and 20, so this means it's 25 degrees Celsius. Now let's look at this one. The highest temperature is 160 degrees, the lowest temperature is 100 degrees, and the current temperature is 130 degrees Celsius. Now let's look at this one. This is a little bit tricky. This is the tricky one, but I discussed it with you, or I explained it to you in this part, that the higher the number is in the negative, it means that the lower the temperature. So this means that the high temperature actually have the lower value, the lower number. So this means minus 10 degrees. The lowest temperature is actually the highest number, but in negative, so this means it's going to be minus 40 degrees Celsius. The current temperature is the temperature liquid reaches, which is minus 20 degrees Celsius. The last one is very easy. The highest temperature is 90 degrees, the lowest one is 20 degrees, and the current is the same as the highest, because the liquid reached all the way to the end of the thermometer. This means 90 degrees Celsius. Now let's start our lesson for today, guys. We're going to talk about heat or thermal conductors and insulators. What are conductors and insulators? Conductors, at the beginning, conductors are the materials that allow or let heat pass through them easily. So this means that conductors help the heat to go through them or to flow through them very easy. Thermal conductors and insulators, as I told you, the insulators is different from the conductors, because the insulator do not let or allow heat move through them easily. So they are not really welcoming the heat to go through them or to flow through them easily, and that's why they called it insulator. We actually discussed conductors and insulators before when we were talking about electricity in the second trimester, this last trimester, and we also talked about electric conductors and electric insulators. And we said that the electric conductors is the ones that help the electricity or let the electricity flow through them, while those electric insulators which do not let the electricity flow through them. It's the same, but here instead of using the word electricity, we're going to remove it and put the word heat. So heat conductors is the materials that allow heat to flow through them, while heat insulators is those who do not allow heat to flow through them. So metals are the most famous electric conductors because they love to allow heat to flow through them, and they actually love to allow, if you remember, they also like to allow electricity to flow through them. So metals are good heat conductors and electric conductors. And that's why cooking pots, which any of your parents are cooking in, or yourself, if you ever helped your parents in the kitchen, you will find cooking pots are made of steel or aluminum, which is types of metals. That's why is that? Because we put food inside those pots, and we want the food to be cooked. In order for the food to be cooked, heat should flow through them, or heat should reach them. So that's why we use metal pots in order to make the heat reach them or flow through them. So cooking pots are made of steel and aluminum, so the food inside heats up quickly and be cooked. Those guys are types or examples of heat insulators, as you can see. And heat insulators include plastics, wood, glass, rubber, wool, cotton, and fur. All of those, they're not really welcoming for the heat, and they don't like it. So they do not allow heat to flow through them. They block it, or they just don't allow them, or don't let them flow through them. So now we're going to play a little game, guys. I'm going to show you an object, and I will let you guess whether this object is a conductor or an insulator. First, we have this kettle, and let me just remind you guys that the kettle, we use it on the stove, or we use it on the top of fire, and we use it to heat things up. So I think I told you the answer. The answer is that the kettle is a heat conductor. Excellent. Now let's see another one. You have a rubber toy. Rubber toy. I hope you got it right. It's a heat insulator. Very good. What about rubber tire? Rubber tire. Yes, it's an insulator. A silver coin, and silver is also a type of metals. Yes, it's a conductor. Let's look at this one. The string. String is made of a type of fabric, so we can say it might be cotton, it might be wool. So think about it a little bit. It's what we make clothes out of it. So this means that this is an a heat insulator. Now the teddy bear, the cute little fur teddy bear. I think I gave you the answer. So yes, teddy bear is an insulator. Next is the nickel knife, and nickel is also a type of metal. Yes, it is a gold ring, and gold is also a metal. Yes, a conductor. Now the key is also, as you can see, made of metal, steel mostly. Yes, it is a conductor. And the paper, I think it's very easy. Yes, it's in an insulator. And then you have the tissue box. I think it's really easy, and it's pretty much like paper. So yes, it's an insulator. Now let's do some classwork together, guys. Starting page 49, worksheet number 5. It says class 4 want to know how long they can keep a mug of hot chocolate warm. They made a cup of hot chocolate and measured the temperature at 72 degrees Celsius. So the first question says, can you think of 3 different insulators they could put around the mugs to keep the hot chocolate warm? I think I gave you several examples and you already know some, so I'm going to give you like 2 or 3 seconds to think about 3 different insulators that could be used in this situation, and then come back to see what did I choose. So the first answer I chose is plastic wrap, for example, and there is the piece of wool or a piece of cardboard. The next question, class 4 decided to use number 1 tin foil, number 2 brown paper, and number 3 bubble wrap. Now let me tell you something about tin foil. Tin foil is actually tin is a type of metal, but we consider it a very poor kind of insulator because it conducts heat very well, but still it like reflects heat back. So we consider tin foil is a poor insulator. It's not a conductor and it's not a very good insulator. It's something in between, and that's why we call it a poor insulator. So the question says, which insulator do you think would be best? So there are 2 things that we can use over here, but there is one that is preferred due to its thickness and due to how good of an insulator it is. So I will let you think about it a little bit and then come back to find out if your answer is right or wrong. So the answer that I chose is bubble wrap, because guys, plastic wrap is a really good insulator, and it really does not allow the flow of heat through it. The third question says, which insulator do you think have the least effect and why? I think I told you the answer at the beginning while I was reading the question, so I will let you think about it and think about the reason why this is the least effective insulator. So the answer would be, of course, the tin foil, because it is a very poor insulator and it will allow the heat to radiate through it and to the surrounding air of the cup. Now question number 4 says, if they cover 3 mugs, one with brown paper, one with tin foil, and one with bubble wrap, and poured out hot chocolate into the 3 mugs and measured the temperature every 5 minutes, do you think this would be a fair test to find the best insulator? Let's look at this. They have 3 mugs and they are choosing 3 materials, so this means that they are changing only one thing, which is the type of material that we are to cover the mug with. They poured hot chocolate into the 3 mugs, so it's the same drink into the 3 mugs, and measured the temperature every 5 minutes for all the 3 mugs. Do you think this would be a fair test? Yes, I think this would be a fair test as long as they use the same type of cup and poured the same amount of hot chocolate. And also if they started all of the of measuring cups with the same temperature, which means that all of the hot chocolates poured to the 3 mugs are of the same temperature. Number 5 says, if the temperature of the 3 different drinks was different at start. This is exactly what I was talking about. We have to start with the same temperature in the 3 drinks. So if they are different, would it be a test? Of course not. The next worksheet is page 50. They want us to specify the material and then find out if it's an insulator or a conductor, and the first one is done for you. So here they have a kettle and it's made of plastic, and this is an insulator. I think it's like a toy kettle or something. Now next is the baby spoon, and we know that the baby spoon is mostly not made of metal, so that it won't hurt the mouth of the little baby. It's mostly made of plastic, so this means that the baby spoon, is it an insulator or a conductor? Yes, an insulator. Now the table mat, and the table mat is the piece of cloth that we put on the table in order to put anything that's hot on it, or if you want to put it as a piece of something to beautify the dining room, and you put all the culinary on it. So this means that the table mat, it's made of cloth, it's made of cotton cloth, and this will make it an insulator also. Now let's look at the spatula, and the spatula is a little bit tricky because it has two parts, the bottom part and the upper part. I think it's very easy. The bottom part is made of metal, of course, and the upper part is made of plastic. So this means that the bottom part is a conductor and the upper part is an insulator. Oven glove, and I think this is a very easy question, because we use oven glove in order to get the hots from the oven without being burned. So this means that the oven glove is made also of cotton cloth, and this will make it an insulator. So now we have the serving spoon, and it's very obvious that it's made of metal. So it is made of metal, and the metal is of course a conductor. Now the oven dish is the Pyrex dish, the thickened glass dish that we put inside the oven. It doesn't matter as long as we know it is made of glass, and that will make it a good insulator. Next is the wooden spoon, and I think it's very obvious what is the material that it is made of. Wood, exactly, and that will make it an insulator. Last is the frying pan, and the frying pan is the type of pots or pans that we heat things up in or cook things in it. So it is made of course of metal, and it is a good conductor of heat. This is your homework, guys, page 46, 47, and 48. This is page 46. It's just a bunch of questions that summarize up or wraps up all the lesson. Question 1 says, when you hold your hands around a mug of hot chocolate, your body gets warmed. Why? We discussed this the last lesson. We said that it has something to do with what happens to the heat and how does it move. It's very easy. I think you will get it immediately. Number 2, a winter scarf is a good example of thermal insulator. They want you to say why. Number 3, a hot drink is used in a thermo flask, and a thermo flask is a type of flask that keeps things inside it hot. So I want you to think why do we put the hot drink inside the thermoflask, and how does the thermoflask work? Is it an insulator or a conductor? Number 4, cooking pots are made from metals while the handles are made of wood. I think all of those questions are like give reason questions. Why do we make cooking pots out of metals while their handles made of wood or plastic? Number 5, you are having a hot dinner on a cold day. What happens to you if you don't eat it straight away? So you have to also talk about how heat moves. Number 6, you are having a cold drink on a hot day. What will happen to you to it if you leave it for a long time? It's the opposite of the last question. Next is page 48, and here sorry, this is 47. You have two questions here. The first one, what happens to the liquid in a thermometer when the air around it gets warmer? So they're talking about the mercury or the alcohol inside the thermometer. And number 8, what do the marks on a thermometer show? What are they called? I want you to think about it and maybe make a little search about what the marks are called. The next page is page 48. As you can see, this is a really easy one. You just have to write below each one of those pictures whether this item is an insulator or a conductor. That's it for today, guys. We're going to watch a little video about an experiment to differentiate between heat conductors and insulators. I want you to check your Google Classroom, of course, for your homework, and also for the uploaded practice worksheet and its model answer, and this is related to your next week quiz. But I don't want you to depend fully on the practice worksheet for studying. Before answering the practice worksheet, please watch all the videos that I have uploaded on Moodle, and I have uploaded yesterday some extra videos on the Google Classroom. I also uploaded the PDF of the entire lesson. I want you to study it very well, and then start answering the practice worksheet and look after that for the model answer in order to check your answers. Now this is it for today, guys. Have a lovely weekend. I hope you enjoy the next video. See you next week, and bye bye.
Hey everyone, it's Danielle from Cool Science Experiments headquarters, and today I'm going to show you a simple experiment, and we're going to learn how different types of materials conduct heat. Are you ready? Let's get started. To begin, you're going to take a small glass bowl, and inside you're going to place 3 spoons. 1 spoon that's made of wood, 1 spoon made of metal, and 1 spoon made of plastic. Then you're going to take a small pat of butter, and you're going to place it on the top of each of the spoons. So once you have the butter on the spoons, you're going to put a bead in the butter on each of the spoons as well. And then after you have the beads and the butters on the spoon, you're going to straighten out the spoons so they're all laying evenly. And now it's time to move to the next step. For the next step, you're going to take some hot and just boiling water, and you're going to slowly pour it into the bowl. You want to make sure that the spoons do not fall into the water. Once you have the water in the bowl, we're going to wait and we're going to watch to see what happens. Can you tell me, why did the bead move down the spoon that was made out of metal, but it stayed at the top of the spoons that were made out of wood and plastic? Leave a comment below to submit your guess, and then visit CoolScienceExperimentsHeadquarters.com to find out the answer. You'll be able to print out instructions for this experiment, and you'll find many more that you can do at home too. Thanks for watching, and we'll see you next time.
I hope you enjoyed the experiment. Click the button to subscribe.